Alright, there's a video for 3HT about exercise 54. It's about quadrilateral ABCD, which we can see here, ABCD. And we need to calculate length dP, angle S, and also QR. Well, first we're going to calculate dP. So let's take a look at the shape. dP is over there, as you can see. So we need to find a triangle where dP is in. So that's DQP. See that? This triangle. Now we can either use the tangent, sine, or cosine if we also know an angle, but we don't, so we're not going to use that. We can use the Pythagorean theorem if we know two sides, but we only know one side. So we have to use similar triangles. So I have to find another triangle that's similar to DQP, and that is ASP. This very big one. See that? So we have, I'm going to write that over here, triangle DQP is similar to triangle ASP, so like that. And then I'm going to make a ratio table, and in that ratio table I'm going to write down that DQ is 1.5, right? And the length that we want to know is DP. That's the one that we don't know. And then in the big triangle we have AS, and AS is 6, and then in this triangle here that's AP. So we have a bit of a problem because we don't have anything here. If we knew AP, we could have done 1.5 times AP divided by 6 is dP. So what you have to do now, maybe you remember this from chapter 2, you have to call this length x, for example, because if this length is x, that means that this length is x plus 3. And then if you want to solve that, then you have to make a equation. So we're going to do 6 times x equals 1.5 times x plus 3, and then don't forget these brackets. So we're going to work out the brackets. So you have 1.5x plus 4.5. That's what you get when you work out the brackets. And here you have 6x. I'm going to remove the 1.5x on this side. So that means that on the other side you will have 4.5x left. So 4.5x equals 4.5. So that means that x is 1. And the question said calculate dP. So dP is 1. And that's the answer for A. Then now we need to calculate angle S. So if you take a look at the picture, angle S is this angle, and now we can calculate it because we know how big AP is, because if dP is 1, AP is 4, and this length is 6. So to calculate angle S, we're going to use the tangent. So angle S is the tangent, because we're going to do the opposite side divided by the adjacent side. So 4 divided by 6, and if you calculate that, you get 33.7 degrees. So you see that B is a lot easier than A. This is kind of difficult. I think a lot of people forgot that or still find it difficult, you know. And then we're going to calculate the exercise C. Calculate QR. Alright, so QR is this length from here to there. Yeah. So that's kind of annoying to calculate. There are multiple ways to calculate it though. One thing that we could do, because we can calculate this whole length, PS, and then we can calculate PQ and RS. And then if you do that, you can subtract it from the whole length, and then you have this. We can also calculate CQ, because we already know that. CQ is 2.5. So if we, for some reason, we know what this is, we can then use the Pythagorean theorem to calculate QR. And I think that's the easiest way to figure this out. So I'm going to write down that we already know that CQ is 2.5, because 2.5 and 1.5 together is 4, right? Then I want to calculate CR, so then we have to use a ratio table again. We can use triangle DQP and also triangle CQR then. So I'm going to write down over here, triangle DQP is similar to, this is a Q, it's similar to triangle CQR. And then we're going to make a ratio table, and then we have DQ. Well, I can show you here, but you can also see it in your own book. DQ is 1.5, and DP we calculated earlier, there was 1, right? And then in the other triangle we have a CR, and that's the one that we, actually I wrote this down in the wrong place. CR should go over here, that's the one that we want to calculate. And CQ, we knew CQ is at 2.5. So if you want to calculate CR, then we do that in the following way, right? You do 2.5 times 1, this times that, divided by 1.5, and then you get 1/2. You can also do 1.6667, right? But then this is more exact. So once we have that, we can now calculate QR. So I'm going to calculate QR over here. Because if you want to calculate QR, we can use the Pythagorean theorem. We can do CQ plus CR squared. So the square root of CQ squared plus CR squared, and that's 1 2/3, right? And if you calculate that, then you get rounded off at 3.0, so the length is just 3. And this was exercise 54. I do have to say this is one of the most difficult exercises that we've done so far, right? Because you have to do like a lot of different things. You have to do the here we did tangent, but here we have to do the ratio table and then also the Pythagorean theorem. But hopefully you could follow it. Thank you for watching. Bye bye.